In section 6.4c, we're going to be doing a couple types of factoring. We're going to factor trinomials and also factoring the sum and difference of cubes. So what we're going to do first, no matter what type of factoring you do, you always want to pull out a GCF. So step number one, we want to do a GCF. And again, I'm looking at the smallest number. I know the factors are 1, 2, 4, 8, and 16. And these are my choices to factor, pull the greatest common factor out of all of them. 16 obviously will not work, neither will 8, and 4 will work in both of them. And then we're going to look at how many m's I can take out of all of them. Well, one has 5, one has 3, and this one has 1. So what they have in common is 1m. So our greatest common factor is 4m. So when I rewrite this, I'm going to say divide everything by 4m. So this is going to be 4m on the outside. And then I have 6m to the fourth, dividing the numbers, subtracting the exponents, minus 5m squared, again dividing the numbers, subtracting the exponents, minus 4. Okay, now, yesterday we factored by grouping, but we had to have 4 terms in order to factor by grouping. So what we're going to do, we're going to rewrite this middle term and group it into, or make our trinomial into a polynomial with 4 terms. Then we can use our grouping. So what we're going to do over here to the side, math is a lot about rewriting. I'm going to rewrite this, and in order to do that, this is one technique. There are several techniques you can use to factor, so if this isn't something that you like, you can try another technique. A times C, this again is A, B with a sign, and C. So we want factors of A times C. So when we multiply A times C, we're going to get negative 24, and they have to sum or add up to negative 5. Let's make that in red. So they sum to B, and B is negative 5. Okay, now we did this earlier in the year, so usually, I mentioned before, what I do is I just start counting to make the factor pairs. I know that 1 works with 24, I know that 2 works with 12, I know 3 works with 8, I know 4 works with 6, and 5 does not work, then 6 will work, but 6 and 4, that's already repeated, so we don't have to write it twice. 6 times 4 is the same as 4 times 6. Now, let's look at what we need to multiply to. We need to multiply to negative 24. So that means one of these numbers in our pairs has to be negative. But we need to add to get negative 5. Well, this one is pretty clear that it's not going to work. If I made one of these negative, I made that negative, that would not give me a negative 5. Now, let's look at 3 and 8. If I made the 3 negative, and I multiplied, I'd get negative 24, but I would only get positive 5. And I want a negative 5. So I'm going to switch my signs here. Checking again, this factor pair, I'm going to get negative 24 when I multiply, and when I add, I'll get negative 5. So that's the factor pair that I want to use. Now, just like before, I'm going to put a box around my GCF that I pulled out so I can remember to write it down at the end. And now, this 5m squared is going to be split into 3m squared minus 8m squared. It'll still equal this. It's just going to be out into 4 terms, so we can factor by grouping. So 6m to the fourth plus 3m squared minus 8m squared minus 4. Now we're back to what we did yesterday. So let's look at these two at a time. We're going to look at these two and just ignore this. So biggest number I can pull out is 3, and I can pull out an m squared. So I'm going to divide by 3m squared here, 3m squared here. That's going to leave me dividing the numbers to, subtracting the exponents, m squared, and then dividing the numbers plus 1, and that's just going to also be 1. Okay, now I always want to take this sign straight down, because that's going to be a minus. And then I can divide both of these. Biggest number I can pull out of both of them is 4. So it's actually going to be a negative 4 because of this sign. Dividing the numbers, subtracting the exponents. Now this one doesn't have an exponent, so this is just going to say m squared. And then a negative and negative is going to give me a plus 1. Okay, now just like yesterday, once we group the first time, we group again. And I needed to write that minus 4 right here. Okay, so grouping again, I see that I have the 2m squared plus 1. Can cross that off. And what I'm left with is 3m squared minus 4. And then I need to remember that I have this 4m GCF out there. So if I were to FOIL this and then multiply by 4m, I would get what I started with. Oops, let me slide that down a little bit. Way up here. Now, the second thing that we need to do is the sum and difference of cubes. So a cube is when you take a number and you multiply it by itself 3 times. So let's just write some cubes off to the side here. We have 1 cubed. 2 cubed is not 6, but it's 2 times 2, which is 4, times 2 again, which is 8. And 3 cubed, which is 27. 4 cubed, which is 64. 5 cubed, which is 125. 6 cubed, which is 216, and you could keep on going. So this is a particular method that only works if your first term is cubed and your second term is cubed. Now what happens is you just basically use these 2 templates. This is for the sum, so that means you are adding. This is for the difference of 2 cubes, so that means you are subtracting. So if the sign is positive here, the pattern is plus. So positive, plus, minus, plus. So it's always, the first sign is always the sign that you see in your polynomial. So plus, minus, plus. If the sign, first sign is negative, first sign here is still negative, the pattern is minus, plus, plus. Okay, so different type of polynomials, some are difference of cubes, but we're still going to pull out a GCF first. So we always have to ask ourselves, is there a GCF? And if I look at these, I can see I can pull a 2 out of both of them. So it's going to be 2, and then I can also pull out an x squared. So I'm going to divide by 2x squared. So now I have, inside my parentheses, I have x cubed and then minus 8. Okay, now minus 8 is a perfect cube, or is a cube, so we have it right here. And x cubed is also a cube because that's x times x times x. What gives you x cubed. So what we're going to do is we're going to take the cubed root, or I'm going to ask myself, and we already talked about this, the cubed root of x cubed is just saying, what do I multiply by itself? 3 times to get x cubed. And we've already identified that as x. So the cubed root of x cubed, and basically if you take the cubed root of a cube, you get, these are opposite operations here, so you're just going to get whatever the variable is. So we need to identify a and b. So we're going to let this, so if this is x, that's going to be our a. And if we take the cubed root of 8, it's 2 times 2 times 2. So the cubed root of 8, what number do I multiply by itself 3 times to get 8? That's going to be 2, and that's going to represent our b. So now what we're going to do is we're going to fill out this template. We have 2 terms multiplied by 3 terms. So again, I'm going to put the box around that GCF so I don't forget about it. And anytime you have a sum or difference of cubes, it's I call it a 2 by 3. You multiply 2 terms times 3 terms. So we'll just write 2 terms and 3 terms. Okay, now, because this is a minus, this minus sign is going to go right here. And then the pattern for minus is plus plus. So I'm going to fill those in. And then if you look here, this is a to the first power. So think about in the first set of parentheses, you raise it to the first power. In the second set of parentheses, you raise it to the second power. And then in the middle, you just multiply a times b. So a, b. All right, now we said a is going to be x for our particular problem. So I raise it to the first power. That's going to be x. I raise b to the first power. So that's going to be 2. And then here, first set of parentheses, you raise it to the first power. Second set of parentheses on the outside, you raise it to the second power. So b is going to be raised to the second power. So this is going to be x squared. And then b, so 2 gets squared, which is 4. And then in the middle, I multiply a times b. So that's going to be 2x. Then I'm going to bring this 2x squared down. And that's my final answer. So you basically have a template that you figure out what your a and b are going to be, and then you can just fill all this in after you fill in your signs. Okay, you have a couple to try.